Hello everybody. So this week we are going to take a look at section 6.4, which is our inequalities, or a continuation of our inequalities that we started to learn about last day. So if we do a quick refresher on what we saw last day, or last week I should say, we learned about inequalities, all these different inequality signs, talking about less than, greater than, or the less than or equal to, or the greater than or equal to. Then we took a look at how we see inequalities every day in real life, and also how to create an inequality statement using some variables to describe what we might see, either as a speed limit or a height requirement or something like that. And we also saw how we can graph the answers to these types of inequalities. Okay, so today we're going to take the next step, and we're actually going to be solving some of these inequalities using algebra. Okay. The good news is we pretty much already know how to do this. We took a look at how to go through and how to solve equations using algebra. So now we're going to take a look at how to solve inequalities, and they're pretty much the same thing. So let's take a look. So we're going to do this question first. Solve for x in the inequality x plus 2 is greater than or equal to 6. So what we're going to do to start is, instead of having it as x plus 2 is greater than or equal to 6, we're going to change it just to a normal equation, something that we're familiar with already. So we're going to change that inequality sign to an equal sign, which is what I've done right here. Okay? So this is an example of an equation that we've seen before. And the question I'm asking you here is, what is the first step that we would take to solve this equation? Well, we would take a look over here on the left, and we'd notice that the x is not by itself. So we would have to use our opposite operation in order to get it by itself. So here we have x plus 2. So the operation that's attached to the variable is addition, plus 2. So of course the opposite is going to be subtraction. More specifically, we're going to be subtracting 2. That would be the first step we would take, right? And we'd subtract 2 from both sides, and of course we would get x is equal to 4. But the whole point of doing that is to show you that it's the exact same thing with inequalities. So now we're going to go back to the inequality. X plus 2 is greater than or equal to 6. So the first thing we're going to do, like we just said, is we are going to subtract 2 from both sides. When we do that, of course, on the left, the 2's cancel. And we're simply left with x is greater than or equal to 4. And that's our answer for that question. So what is this saying? This is saying that if we take our original equation, or I guess I shouldn't call it an equation. If we say it's an equation, that means there's an equal sign. So I should say this is an inequality or an inequation. Take our initial inequality, and as long as we put a number in for x that's equal to or greater than 4, it will make the inequality true. It will be satisfied. Okay, so that's what I'm saying here. We could pick some values that are equal to or greater than 4 and check. So what's a number that's equal to or greater than 4? Let's use 5, right? 5 is greater than or equal to 4. So let's say x is equal to 5. And we can check, right? So it'll be x plus 2 greater than or equal to 4. So we're going to take this number and make our substitution there. And we can simplify that. So 5 plus 2, of course, is 7. Or whoops, sorry, this should be a 6. We get 7 greater than or equal to 6. So is that true? Is 7 greater than or equal to 6? And of course, yeah, it is. 7 is greater than 6, so we know that it's true. So we know our answer worked. So that's good. How would we plot our answer on a number line? Well, we got an answer of x is greater than or equal to 4. Okay, so 4 is over here, obviously. So that is greater than or equal to. So we know we're going to be using a closed dot to indicate that it can be equal to. Remember, if it's greater than or equal to or less than or equal to, we use a closed dot. If it's just greater than or if it's just less than, we use the open dot. Okay, so x is greater than or equal to 4. So if it's greater than, we need to go to the bigger numbers. So are the bigger numbers to the right of 4 or are they to the left of 4? Well, the bigger numbers are to the right. So we will indicate our answer like so. So as we're graphing here, we can see that any number that's 4 or bigger as we move to the right will satisfy our original equation, just like our answer told us. Okay? So let's take a look at the next one. Let's do one that's a little trickier. We got some decimals here. Solve for k in 6.2 is less than or equal to k minus 4.5. Okay, so again, let's just pretend that this is an equation, right? If we just said this is 6.2 is equal to k minus 4.5, what's the first thing we would do in order to solve for k? Well, we would take a look and see what's stopping the k from being by itself. In this case, the negative 4.5 is attached to the k. That's what's preventing it from being by itself. So if the if the operation that's there is subtraction, well, we want to use our opposite operation to get it by itself. And of course, the opposite of subtraction is going to be addition. So we can come down here, 6.2 less than or equal to k minus 4.5. So we'll come in here, we'll add our 4.5 to both sides. The negative 4.5 and the positive 4.5 cancel out. So what we have on the left is 6.2 plus 4.5, so that's going to give us 10.7 less than or equal to k. All right, so basically that's our answer. We can switch it around if we're used to seeing the variable on the left. So if we want to, we can switch those. If you decide to do that, make sure you also switch your inequality sign. Okay, so you end up getting k is greater than or equal to 10.7. And it would seem that I did not give myself a proper number line to answer this. Unless I messed up my answer. No, the answer's fine. I'll tell you what, let's go up by threes instead. How about that? Give ourselves enough room here. So let's go, let's say this is 3, let's say it's 6, 9, 12, 15. See, negative 3, negative 6, negative 9, negative 12, negative 15. So 10.7, well, that's going to be somewhere here, right? So let's say that's about 10.7 right there. It's greater than or equal to, so that's going to be a closed dot. And, well, again, it's greater than, so we're going to be heading that way. Okay? All right, let's do a word problem. All right. Jake wants to board his dog while he goes on vacation. Basically babysitting. If you don't know what boarding means, he's going to drop his dog off for somebody to look after. The first place he looks at, business A, charges him $90 a day, or sorry, $90 plus $5 a day, and business B charges $100, so it's more upfront, but it's $4 per day after that, so it's cheaper per day. How long does Jake have to board his dog at business A to be less expensive than business B? All right. So let's go over here. We'll do business A. All right. So what we're going to do is we're going to pick a variable to be x, and we're going to say that's the number of days. Okay? And we're going to do the same with business B. All right. So let's make an equation that describes A and B, how much money Jake is going to pay. So business A, regardless, is going to charge $90 just to get in. But to that, we're going to add the $5 every day extra. So if x is our number of days, that means 5 times x is going to be the amount of money that Jake is going to pay total for his dog to stay there. So it's going to be plus 5 times x, right? That's the amount of money Jake is going to pay to board his dog at business A, depending on how many days he leaves it there. Then for business B, well, business B charges $100 to get into the door, but they only charge $4 a day extra. Okay? X is still a number of days. So the question is, how long does Jake have to put his dog in at business A to be less expensive than business B? So if business A has to be less expensive, well, we're going to bring these together now. E is going to be less expensive than B. Okay, so that's the question. What does X have to be in order for business A, which is on this side, to be less expensive than, that means less than, business B, which is on that side? Okay, so if you guys remember, what we want to do is we want to get all the variables to one side. We want to get all the constants to the other side. So what I'm going to do here is I'm going to put all the variables on the left. So that means I need to move this 4x. So I'm going to subtract that 4x because it's a positive 4x. We want to use the opposite to move it. Okay, so when I do that, the 4x's cancel out. So I'll get 90 plus, well, 5x minus 4x. That just leaves us with 1x. And now I want to get all the constants to the other, so I can just move the 90 to the right-hand side. So it's a positive 90, so if I want to move it to the other side, I need to subtract 90. Okay, so those 90s cancel. And what I'm left with is x is less than 100 minus 90, of course, is just 10. And that's our answer. So remember, x was number of days, So that means if we want business A to be less than business B, Jake has to leave his dog at business A for less than 10 days. Anytime after that, then business B becomes cheaper. Okay, so I'll say therefore business A is cheaper if Jake boards his dog for less than 10 days. Okay, so hopefully that makes sense. If you guys have any questions, make sure to send me a message in the Discord. I'll have office hours every Monday and Wednesday from 11 a.m. till noon. Of course, we got the Easter Monday coming up, so I won't be there that day. But yeah, other than that, go ahead, start the assignment. Question 15 is a challenge problem, so don't worry too much about doing that. And as always, you can do every other question for these questions, right? So do every numbered question, but just do every other lettered question, right? So do A, skip B, do C, right, etc. Okay, so stay safe out there, guys, and I'll see you next week. Bye.